So you need to express this in exponential form. So try to recollect this formula. A power x equal to m implies and implied by log. When you're converting the exponential into logarithm or logarithm into exponential, the base remains the same. That's what the point that you need to remember. The a remains the same. The one which is away from the base will come along with the base. The one which is along with the base will go away from the base, right? So same formula you can use in both ways. So if you recollect this formula, then it is easy. Now you need to convert this into exponential form, right? So the base remains the same. First write the base, the 2 as it is you write it. And the one which is away from the base, write along with the base. The one which is along with the base, write it away. Now you know that 2 power 7 is 128. So verifying the validity of the statement is also easy for you. So these three BCD bits are similar to 1A, and you need to try in your own. So they're given this expression, the 2 log 2 plus 3 log 3 plus log 5, and need to write this as a single log function. So for that, you need to use the formulas that we already learned. I'll just give the formulas that you already learned, which are useful for us in this. The first, log a power m equal to m log a. That's the formula that we are going to use first. And after that, we're going to use log a b equal to log a plus log b. So I'm not going to write all the formulas which you have in logarithm. So I'm going to write the formulas which we are going to use in this particular problem. And these two formulas, of course, the formulas we are writing like this, but we use this from RHS to LHS. The formula is not just LHS to RHS every time. Both ways we should be able to use it. So m log a is present. You should be able to write that as log a power m. And log a plus log b is there. You should be able to write that as log ab. So if you use that, first 2 log 2 can be written as log 2 square, and 3 log 3 can be written as log 3 cube, and log 5 remains as log 5. Yeah, the formula, this log AB can be extended for any number of numbers in multiplication. I mean to say log ABC can be written as log A plus log B plus log C. So even this formula you can apply from RHS to LHS. How we are going to apply that formula, if you see here, log A plus log B plus log C can be written as log ABC, log 2 square into 3 cube into 5. So now we are able to simplify and write it as one log function, right? So the 2 times of 5, always whenever a 2 and 5 are there in a product, we'll write them together as 1 0. The product is 10, and remaining numbers 2 into 3 cube is 27. 27 into 2 is 54. So 540, right? So I want you to try these 3 similar homework problems to 2A, 2B, 2C, 2D. So simplify, we always mean that write it as a single log function, and here minus is there. So the same formulas that we used in the last problem, that log a power m equal to m log a, of course. You are not writing any base, means this formula holds for every base. So you can write any base b. And also that log a by b equal to log a minus log b. This is the other formula. And the base, you can write anything like some e. You can write any base. So even this time also we are going to use this formula in reverse order only. So first we'll write, and we can, if there is no base, we write throughout the calculation without the base, and if base is there, then we do. And if the bases are different, they are given, then we can't apply this formula. That's the point that you need to, that's a new point here. So when the base is same, then only you can apply that formula. So first of all, log 7 square base 5 minus log 14 base 5. After that, log a by b formula, the 7 square by 14 base 5. So which is equal to the log 1 7 get cancelled in this 14 two times. So 7 by 2, log 7 by 2 the base 5, right? Third main is kind of similar to the second one, but you need to deal with the expression if the base is given also. But only thing you need to check when you're applying the formula and base is given is the bases should be the same to apply the formula. So that's the new point in it. If the bases are same, then you can apply that formula. So try these 3b, 3c, 3d also. So it's already in simplified form, a single log function. Then how will find the value of this? So then we need to think about this formula. The log a base a equal to 1. Yes, of course, log a base a is equal to 1, but how will use that formula here? These two are not same. Then we need to use this formula that we already used in the previous problems. Log a power m equal to m log a. So you need to use this formula. These two formulas you need to use in this problem. How we'll use that formulas means, first of all, whenever the base is one particular number, try to write this value with log in terms of that base in exponential function. So you can write this 32 as 2 power 5, and this base is also 2. So after writing this 32 as 2 power 5, then you can think about using this formula. This time from LHS to RHS, 5 log 2 base 2 and 5 into log 2 base 2. This time you need to use this formula, which is 1. So 5 times 1 is 5, right? You can try these problems using the similar logic, the same logic. So if both are log functions, we can do something. Then here 1 and plus log 2, log 3 base 2 is there. Then what to do with these kind of problems? The formula that we're going to use here is again log a base a equal to 1. Log a base a equal to 1. And also that log ab equal to log a plus log b, of course in reverse order, right? So those are the two formulas that we're going to use. But how we'll use that formulas? So one can be written as log 2 base 2. Yeah. So I'll just write the expression also, better understanding. So the given is log 3 base to 1 plus, and that is equal to 1 can be written as log 2 base to 1 can be written as log 100 base 100 also. But we are writing log 2 base 2 because the second expression is with base 2. So the log a plus log b is log ab, the 2 times of 3 base 2, right? Log a plus log b is log ab. The base is same, right? So now we are able to write this as log 6 base 2. So that's what they mean. Simplify and write it as a single log function. You can try simplifying these three similar expressions. Yeah, I know, like the problem that I explained looks much simpler than what I ask you to try. That's why I use the word try. And if you're not getting, then I'll definitely explain. So they are given the log 3 base 5 as A and then log 5 base 7 as B. So you need to write this in terms of log 3 base 5. So the formulas that we're going to use here are log A power m to the base B power n equal to m by n log A base B. This is the formula that we're going to use. Of course, that log AB equal to log A plus log B in reverse order. I don't think we need, okay. I don't think we need this. Okay, we'll see. So then this is equal to this expression, the log 9 base 25 plus log 25 base root 7 equal to. We discussed some formulas there where you cancel these two, but these two are in multiplication. You could do that. They are in addition. So you need to be careful. And you can write this 9 as 3 square and 5 as 25 as 5 square and 25 as 5 square, 7 as 7, root 7 as 7 power half. Now if you use this first formula, the first one will be 2 by 2 into log 3 base 5. The second one will be the 2 by 1 by 2, the log 5 base 7. So the 2 get cancelled and log 3 base 5 is already given as A. And 2 by 1 by 2 will be 4 and log 5 base 7 is already given as B, and that's what they need. Right? So you can try these 6B, 6C, 6D, similar to those that 6A. So the formula that you use mainly here is this one. Of course, sometimes based on the problem, you may need to use the other formulas.